Hello, this is Dr. Mears, and today we are going to be learning about trigonometric ratios in the unit circle. So first, let's look at a unit circle. It is a circle with its center at the origin and a radius of 1 unit. So anywhere that we measure the radius, it's always going to be 1. 1 here, this is 1, that's 1, that's 1, everywhere it will be 1 unit. So notice on this coordinate plane, we have the coordinate 1, 0. We have the coordinate 0, 1, negative 1, 0, and 0, negative 1. Okay, let's look at how we read a unit circle's angles. So all angles start on the positive x-axis. What is that? So all of them start on this x-axis right here. Let's sketch that in. This is the positive x-axis right here. This is where they all start. So if we turn counterclockwise this way, then they're going to be positive angles. If we turn clockwise, so we start at this positive x-axis right here, and we go clockwise, they're going to be negative angles. That's supposed to be a negative right there. Okay, let's look at the quadrants. There are 4 quadrants. Notice we are labeling the angle measures that they actually make. So the first quadrant is between 0 and 90 degrees. The second quadrant is going to be between 90 degrees and 180. So from here to here. The third quadrant is between 180 and 270. And the fourth quadrant, we go back from 270 to 0. And notice they're all 90 degrees. First quadrant, 90 degrees, second, third, fourth, and so on. So, perfect 90-degree mark all the way around. Okay, let's keep exploring. Let's investigate a few angles in degrees and radians. So when we start on the positive x-axis here, working our way counterclockwise to the y-axis, so from here to here, this is going to be 30 degrees. So this angle right here is 30 degrees. In pi radians, it's pi over 6. I want you to notice something. This 30 degrees, 30 here, 3 here, it's always going to have the 6 in the denominator. Pretty cool. Okay, let's look at the next one. From our positive x-axis, going counterclockwise to this next triangle here, this angle right here is going to be 45 degrees, or in pi radians, pi over 4. Notice, if this is 45 with the 4, it is going to have a 4 in the denominator. Okay, let's look at the last angle measurement, all the way up to this one. This is 60 degrees, or pi over 3. Again, notice the 6, and there's a 3 in the denominator. So these are actually opposite here and here. That will always happen. There's little nuances that you're going to notice about this unit circle that are pretty cool. Okay, so now that we've explored a few angles, you're also noticing these triangles. That is going to come in handy in a little bit. All right, we're going to expand. I'm going to show you all of the angles in the entire unit circle. If it's a little overwhelming, I'm sorry, but we are expanding this to the entire unit circle. So here's our 30-degree angle measurement right here, or pi over 6. Then we went out to 45, pi over 4, 60, pi over 3, and then we're at 90 degrees, which is pi over 2. Then we can keep going. Remember, we're always starting from here and going counterclockwise. So we have 120, 135, 150. Now we're at 180. 210, keep going, 225, 240, end up at 270. Keep going, 300, 315, 330, and back at 360 degrees, which is 2 pi. Okay. So we're looking at our first quadrant, 30, 45, and 60. This first quadrant right here, this is going to help us so much because if you can master the first quadrant, you're going to see that we can find all of the other quadrants really easy. What do I mean by that? Let's keep exploring. Okay. We can find any point on the unit circle using the angle measure with sine and cosine. Let's see what that would look like. First, we need to understand that the first coordinate, this is x and this is y. And I would like you to understand where it's positive and where it's negative. So in quadrant 1, x is going to have a positive value and y is going to have a positive value. And this just goes back to when we were learning about linear functions and quadratic functions and graphing. Okay, same thing. If we drew the triangle over here and we got our x, y, we're over on the negative x side, but y is still positive. We're still in positive y, okay? If we drew our triangle over here and we did our x, y, what are you going to notice? Right, our x is negative and we're on the down, so our y is going to be negative. And if we drew our triangle over here and we have x, y, our x is going to be positive. We're now back on the positive side of x, but our y is going to be negative. These are important because, as I said before, if we know the first quadrant, we're going to be able, just to adjust the sign, to be able to find any coordinate on this unit circle. How do we do that? We use sine and cosine, or cosine and sine. Looking at this triangle, we have cosine. This is going to be equivalent to the value of x. And we have sine. This side of the triangle is going to be sine. And that is going to be equivalent to y. Okay? So, in the first quadrant, cosine and sine are going to be positive. In the second quadrant, cosine is going to be negative and sine is going to be positive. In the third quadrant, just like here, cosine of theta is going to be negative, sine of theta is going to be negative as well. And in the fourth quadrant, cosine of theta is going to be positive, just like over here. And sine theta is going to be negative. So the signs are going to be just like x and y for cosine and sine. If you want to think cosine is going to match up with your x, these two are going to become one, everybody, okay? And sine is going to line up with y. These two are going to become one. We're just going to be using these in order to get the coordinates for x and y. All right, how does this work? Dr. Mears, I'm thoroughly confused. Okay, rather than looking at triangles and coordinates, let's just take a look at a nice circle. We're in the first quadrant. Here, this is x, this is y. This is going to be xy, which we also know is going to be cosine of theta and sine of theta. Okay, we just did that. Let's give the angle measurement 30 degrees. So let's just find that first angle measurement. So if we want to find cosine, we know we can find cosine of 30 degrees. I want the exact value. You learned this. You actually have a table with exact values that we did a video for, and you can find that if you need to go back to my YouTube and look for understanding sine and cosine. It's there for you. So what is the cosine of 30 degrees? Well, this equals the square root of 3 over 2. So this first coordinate is the square root of 3 over 2 because we did the cosine of 30 degrees right here. I can even erase this now. So you see, since we have an angle measurement, I can get that exact value of x. It's a square root of 3 over 2. How about sine? Remember, this is sine. So we're doing sine of 30 degrees, which equals 1/2. So here we have the sine of 30 degrees, which is the y coordinate, which is 1/2. Isn't that sweet? I know, it's pretty neat. So if we know the sine of 30, we're going to be able to know the sine over, and if we know the cosine and sine in the first quadrant, it's going to carry over to these, and that's what we're going to start to look at. But before we do that, you guys might want the table. Oh, there's my lights. Sorry about that. Okay, you guys are going to want the table. So this was the table that I was talking about before, and we actually explored the 30, 45, and 60 degree triangles in another video, as I said before, so you can look at that if you need to. So for 45 degrees, so here we have our 45 degree triangle. Remember here, this side of the triangle would be cosine of 45 degrees. Cosine of 45 degrees, here you have cosine. 45 is the square root of 2 over 2, right here. So this would be the cosine of 45. That's the x coordinate. Okay, how about the y coordinate? This would be sine of 45 degrees. Sine of 45 degrees, which comes out to be the square root of 2 over 2. Square root of 2 over 2. Right here, square root of 2 over 2. These are the same for 45, which makes it really nice to remember that they are the same answer for the sine and cosine of 45 degrees. Okay, so that's the coordinates for a 45 degree triangle here, or 45 degree angle. Okay, how about 60? So we have 60 degrees. So we have to find cosine of 60 degrees. What is that? That's 1/2. That becomes our x value. Okay, sine of 60 degrees. Sine of 60 degrees is square root of 3 over 2. That becomes our y value. Remember, cosine goes with x and sine goes with y. And it all comes back to this pattern of our special right triangles. Okay, so let's fill out the rest of the unit circle and see how this all works. Filling in the unit circle. Okay, right here. Let's put in what we know, okay? So first, we know that this is going to be 0 degrees. That's 0, which in radians is just 0 times pi, which is 0. And this was 1, 0. That was because, remember, the radius is 1, this is x, and this is y. All right, what else do we know? We also learned that this is 90 degrees, okay? And this is going to be pi over 2. I'm going to use this as the fraction bar. All right, and this was 0, 1. So this is the y-axis, y, and this is the x-axis here. Okay, all right, we also know what else? We know that this is 180 degrees, which is going to be pi, and this is going to be -1, 0. Awesome. Okay, what else do we know? Down here, we know this is 270 degrees. Which is 3 pi over 2, which is going to be 0, -1. All right, keep going. We're back at 360 degrees. This is 2 pi. Same coordinates, x of 1, y of 0, so x, y. Then remember, this is the x-axis here. Okay, questions? No, because I'm on video. Let's keep going. Let's look at the first quadrant because we just went through the first quadrant. We know that this is 30 degrees, which is pi over 6. We found the coordinates to be the square root of 3 over 2 and 1/2. We went through that. This comes from those special right triangles if we drew that triangle in there, and this would be our 30-degree angle here. Next, we have 45, which is pi over 2. And we know that this is going to be the square root of 2 over 2 and the square root of 2 over 2. They're the same, which is really nice. Cosine of 45, sine of 45, same answer. Okay, so that was this angle right here. All right, how about this one? Well, we knew it was 60, which is going to be pi over 3. And so cosine of 60 is 1/2. Sine of 60 is the square root of 3 over 2. That's what we just went over. We used our special right triangles. We used cosine as our x. We used sine as our y. Substituting the answers in, we found exact values of these points. Let's extend this to our second quadrant. Now remember, In our first quadrant, x is positive, y is positive. In our second quadrant, x is going to be negative and y stays positive because we're still up here on the positive y-axis. Let's look at our angle measurements. So we need to go all the way here, okay? So in order to get our angle measurements, we're going to be using 180 degrees. And when you did reference angles, and you learned about reference angles. So to get any measurement, any degree measurement here, all you do is you take 180 degrees and subtract it from this first quadrant. Okay, so we have, this is 60 degrees right here. So what this angle is going to be, this whole angle right here, this is going to be 180 minus 60, which gives us 120 degrees. That's why these little lines are in there. They match up, okay? So those are degrees. Let's do the second one. So 45, we follow it. So this one's going to be 180 minus 45 degrees. That's going to give us 135 degrees. Okay, let's keep going. 30 degrees matches up. So this is 180 minus 30 degrees, which is going to give us 150 degrees. If you don't understand how these are matching up, let's just look at this, okay? If we looked at the negative x-axis here, and we just found this measurement and this measurement are the same. This is 30 and this is 30. Notice it. Here and here, this would be 45, this is 45, okay? And then from here, this all the way up, this is 60. However, we don't start from the negative x-axis, everybody. Where do we start? That's right, we start from here. And that's why we have to go all the way here, and that's why we do 180 minus 60, okay? Now, you changed all of these to radians. I made you do a whole heck of a lot of work if you were in my class. So in pi radians, I'm going to fill this in for you. 3 pi over 4 and 5 pi over 6. So you've done that before, just filling them in. Okay, let's find out what the values of our cosine and sine would be. Now, this is where knowing this first quadrant comes in. Okay, we have 120, which was our reference angle to this 260. So it was 180 minus 60. So these two are, if we add these together, everybody, we would get back to 180. So what we're going to do is we're going to use 1/2 and square root of 3 over 2. If we put this in the calculator as cosine of 120, you would get 1/2, everybody. Let's do it. Make sure we're in degrees. Okay. Cosine of 120, I should get 1/2. But here's the thing. Yes, you're noticing it's negative. Why is it negative? Because the x value is negative. So we're going to put negative in there. Okay. What would the y value be? That would be the square root of 3 over 2. It's going to stay positive because the y value is positive. All right, let's look at 135 and 45. Again, if we add these up, it would be 180. These are joined together. So if we put in cosine of 135, we're going to get the negative square root of 2 over 2. Because remember, this is x. And for sine of 135, we get positive because that's y. So all of your cosine values in this quadrant will be negative. And again, 150 and 30 go together. So cosine of 150 would be negative square root of 3 over 2. Sine of 150 would be positive 1/2. It will always work out like that. I promise you. All right, let's look at the third quadrant. I'm hoping you're kind of picking up what I'm throwing down. The third quadrant, we're going to have to start here and go all the way around, cross 180. All right, so let's see what that looks like. So if we just measure this angle measurement right here, what is that? You should pick up that it's 30 degrees from here to here. These are all 30s, right? 30, 30, and this one will be 30 degrees here. But we don't start from here and go down. We start all the way from the positive. So 30, who does that match up with? Let's follow our line right here. So what we have to do in order to get this big angle is we're actually going to do 180 plus theta. Okay, so let's do that. 180 plus 30. You got it, 210 degrees. 180 plus 60, because that's our next one. There's our bell. And this is, oh, not 60, I'm sorry. The bell threw me off. You got it, 45. Okay, and this is going to be 225. Okay, and then you're right, 180 plus 60. That's going to be 240 degrees. All right, transferring them to radians. This is going to be 7 pi over 6. This is going to be 5 pi over 4. And this is going to be 4 pi over 3. Now, to get our coordinates using cosine of theta and sine of theta, let's just review. In this quadrant, our x is going to be negative and our y is going to be negative, okay? So these two answers are going to be negative and negative. So let's look. This angle right here, we had to do 180 plus 30. So our answers for here, for 30 degrees, was 3 pi over 2 and 1/2. So this is just negative 3 pi over 2 and negative 1/2. Here, we had to add 180 to 45. So it's just going to be negative square root of 2 over 2, negative square root of 2 over 2. And here, we added 180 to 60, so we follow that up. So here are two answers, but you're right. Negative 1/2, negative square root of 3 over 2. I'm hoping that you're seeing we're always going to be going back to here. So this is what you have to remember. That's why I gave you that chart. Once you can remember this, we can fill in everything else. All it is a sign game. That's it. And whether we add or subtract. 180, or now we're in the third quadrant, so we're going to have to go all the way around, okay? But we do know from here to here is 30 degrees. So how do we get here? Well, getting here, we don't use 180 anymore. We're going to be using 360, okay? And we're actually going to be taking away theta. So from here to here is 30 degrees. So this one is going to be 360 minus 30, which gives us 330 degrees. From here to here, 360 minus 45, and that's going to give us 315. From here to here is going to be 360 minus 60, and that gives us 300. Okay? So this is the big quadrant because you have to go all the way around. All right, so what does that look like in pi radians? This is 5 pi over 4. 7 pi over 4, and 11 pi over 6. What does this look like for our cosine of theta and sine of theta? All right, well here, we used 30 degrees. Let's figure out some signs first. Remember, in this quadrant, x is positive and y is going to be negative. So this answer will be positive. It goes with 30 degrees, so that's up here. So it's going to be positive square root of 3 over 2, and y is going to be negative 1/2, because in this quadrant, y is negative. Okay, next, 315, it came from using 45. So, yep, they are the same. So this is going to be positive 2 over 2, because that's the x, and x is positive, but a negative square root of 2 over 2. And our last and final one is going to be dependent upon the 60-degree angle, because that's our angle that we used. So we're going to come up here. Cosine, it's going to be 1/2, but the sine is going to be negative square root of 3 over 2. So it is all tied in. What you really have to remember, I wish you didn't hear that bell all the time. What you really have to remember is this first quadrant that sets it up. Because then in the second, third, and fourth, we're going to be able to find the angle measurement. We're going to be able to find the radians. And then we're going to be able to find that point that it corresponds to. In any quadrant, just by knowing the first quadrant. So this has been the unit circle. I hope it helped. It was a little bit long, but you can watch my next video. It's how to use this unit circle to answer some of our questions in our IB math textbook. Thank you. Hope it helped.